This lecture explains how a white dwarf can come back from the dead. The final demise of a low-mass star is to become a white dwarf. Sirius B is the closest known white dwarf to the Sun at 8.6 light-years. Recall that most stars are in binary systems, as in figure 12.18. Here, two low-mass main sequence stars orbit about their center of mass. In each pair of low-mass stars, the more massive star evolves first. The more massive star will become a white dwarf before the less massive star. As the larger two solar mass star ages, it expands. It can only expand so much before it begins to lose material. If the stars orbit close enough to each other, the material can flow from the giant star to its companion. In this example, the two solar mass star will lose mass when it is in the AGB phase. The material flows onto the one solar mass star. This occurs because the star expands to the point where the gravitational pull of the other star strips away material. This is called mass transfer, and the system is called a mass transfer binary. During this process, the smaller one solar mass star becomes more massive. Eventually, the two solar mass star becomes a white dwarf. When the second star, the one solar mass star, is a giant, it can dump material back onto the white dwarf. So there are two different fates. In the first type, the white dwarf receives a critical mass and erupts as a nova. It then becomes a white dwarf, and the system becomes two white dwarfs orbiting their center of mass. In the second type, the white dwarf attains a mass of 1.38 solar masses and erupts into a type La supernova. The supernova event can completely disrupt the star and leave an isolated giant that becomes a lone white dwarf. As hydrogen collects on the white dwarf, nuclear reactions can start on the surface. Then it gets much brighter temporarily until it erupts as a nova. For a few hours, it can be 500,000 more times more luminous than the sun. The maximum mass for a white dwarf is 1.38 solar masses, known as the Chandrasekhar mass. If material dumped on the white dwarf pushes it over this limit, the white dwarf will explode as the supernova. This explosion is called a type La supernova. The explosion is briefly as luminous as 10 billion suns. Nothing of the white dwarf is left behind. The other star continues to evolve on its own. So, in binary systems, material falls onto the white dwarf from its main sequence companion. When enough material has accreted, fusion can reignite very suddenly as a nova, burning off new material. Material keeps being transferred to the white dwarf, and the process repeats. Like a zombie, the star dies and then comes back to life. Type La supernova may also occur. These tend to disintegrate the stars, so the process no longer repeats afterwards.